Okay, hello everybody. Welcome to this webinar organized by the Research Synthesis in Applied Linguistics Special Interest Group of BAL. My name is Seung Chong. I'm the chair of the committee of the SAIC. And together with me today, who will be hosting the event is Mehdi, who is our event organizer. Before I hand over to Mehdi to introduce today's speaker, I would like to welcome everybody from different parts of the world. I've had a look at the registration form. We have over 110 participants from virtually different parts of the world who will be joining us. So welcome. And I also want to just say a few words about the SAIC and also about BAL. It would just take a few minutes. Please allow me to share my screen. Mehdi, can you tell me if you can see my screen? Because I can't see you.
Yes.
Yeah, okay,
yes.
Perfect, thank you.
Okay.
So, so for everybody who's interested in meta research synthesis or evidence synthesis, we have recently established a special interest group called the Research Synthesis in Applied Linguistics Special Interest Group. And it is part of the British Association for Applied Linguistics. We have a website, and I'll share the link with all of you later on, where you will see some of our events, of course, our SAIC committee members, how to become a member of the SAIC. And we also have like a repository of syntheses in applied linguistics. So if you or your students are interested in doing some synthetic research, there will be plenty of examples as well. So, and also, as I said earlier, this is part of the British Association for Applied Linguistics, and it's a professional and a learned society on anything related to applied linguistics academically. So if you're interested in learning more about the association and maybe consider becoming part of this, we have an annual conference coming up in August in York. So I will share more details in the chat as well. It's a very, very supportive community, especially towards early career researchers. So I would encourage you to have a look and consider whether you would like to be part of it. So that's enough for me. For my welcome. I'll hand over to Mehdi to introduce our speaker and lead us through the day. Thank you.
Well, thank you, Dr. Chong, and hello, everybody. I'm very excited to be here, and thank you for joining us. Today, we are going to, in fact, learn from Dr. Vahid Aryadoust about, on the topic is assessing research impact in applied linguistics, advantages and limitations of Scientometrics. We have this pleasure and we are honored to actually have this session with Dr. Vahid Aryadoust. And for those of you who do not know Dr. Aryadoust, I would like to briefly introduce him. Dr. Vahid Aryadoust is Associate Professor of Language Assessment at the National Institute of Education of Nanyang Technological University, Singapore. His areas of interest include language assessment, meta-analysis, and scientometrics, and sensor technology such as eye tracking, brain imaging, and GSR in language assessment. Dr. Aryadoust has published his research in computer-assisted language learning, language testing, system, current psychology, language assessment quarterly, assessing writing, educational assessment, educational psychology, and a lot more journals. He has also co-authored a number of book chapters and books that are published by Routledge, Cambridge University Press, Springer, Cambridge Scholar Publishing, Wiley, Blackwell, and some other publishers. Dr. Aryadoust has also led a member of assessment research projects supported by educational fund providers in Singapore, USA, UK, and Canada. He's a member of the advisory board of multiple international journals and has been awarded the International Academia Fellowship. Dr. Aryadoust is a strong advocate of knowledge sharing, equity in education, and free education for all as a means of disseminating his experience and knowledge in quantitative methods and theory. He established a YouTube channel named Statistics and Theory in recognition of his outstanding and innovative use of social media. His YouTube channel was honored with the John I'm not sure if I'm pronouncing it right, John Choung Social Media Award in 2020. And I will send the link of his YouTube channel in the chat box as well. So maybe later you can all, in fact, check his YouTube channel. That can be really informative for you. Okay, thank you, Dr. Aryadoust, and thank you for your time here. Please have a little greeting with our audience.
Yeah, thank you very much, Mehdi, for the kind introduction, and Sinwang for the invitation. It's a pleasure to do this talk here at Balzig for research synthesis. Yeah, as Mehdi said, I'm Vahid Aryadoust, and my research usually focuses on language assessment and sensor technologies. In addition to that, I do research synthesis as well, and with specific focus on scientometrics and meta-analysis. So I'd like to share my screen if I could find the share button. All right, I found it, I guess. And here is, okay, can you see my screen?
Yep. Yep.
Oh, so sorry, my screen has been divided into half, so let me duplicate the screen. Oh no, you're not. What you see is okay. Can you see the slides?
Yep, I can.
Okay, awesome. All right, so after a brief greeting, I would like to get started with my talk here, which is about assessing research impact in applied linguistics, advantages and limitations of scientometrics. By the way, I can't see the screen anymore. I just see my own slides. So if you want to prompt me about time or anything else, please just feel free to open your microphone and let me know. Okay, so I'd like to start by providing an overview about review in science. I am not going to limit it only to applied linguistics or the field of language assessment. And as a result, I have chosen 4 types of reviews which are commonly used in science, but the list that I'm presenting here is obviously non-exhaustive. The first type of review is narrative reviews. The second one is systematic reviews. The third one is scoping. And the last one is scientometric or bibliometric. So let's go through them quickly and see what they are, what the limitations might be, and then I'll present my own work. Narrative reviews are characterized by lacking research questions or any pre-specified aims or objectives. In fact, if you ask a scholar in the field of applied linguistics or any other fields to write a narrative review for you, they would start off by writing based on what they assume to be high quality articles or studies that are relevant in their opinion, that are meaningful and important. So if you ask 2 different authors who are expert in a particular field to write a narrative review about how things are going on in that field, there's a very high likelihood that the papers that they choose are partly common and the same between the 2 reviewers of the field, but there are also some papers that are, chosen by specifically by the reviewers. So they may not necessarily agree upon the meaningfulness, the relevance, and the importance of the papers that they choose to review. Narrative reviews are useful. They're common, especially in language assessment, and I'll get back to narrative reviews in a second. The second type of review that I would like to share with you here is called systematic reviews, which are basically they are based on pre-specified criteria to address specific research questions. And when we have specific research questions, you can address them using quantitative tools. Some of these quantitative tools include meta-analysis and clustering. I'd like to draw your attention to the figure on the right-hand side of the screen. This is from our paper, a comprehensive review of Rush measurement, which was published in Language Testing in 2020, in which, among other things, we use this network analysis where we modulated the field of Rush measurement. I mean, the research that has been published in the field of Rush measurement into 2 modularity clusters, as you can see here. And for further information, you can refer to the paper itself. What I'm trying to say here is that when you're conducting a systematic review, you can use quantitative techniques like this. And here I would like to answer a question that sometimes students ask. What is the difference between systematic reviews and meta-analysis? In my view, systematic reviews is a type of review, and meta-analysis is that quantitative instrument that you use in order to answer your research question within the systematic review. The next type of review is called scoping review, and it refers to a sort of review that aims to identify the scope and extent of the available literature on a research question. What does it involve? It involves a broad search of the literature and may include both quantitative and qualitative study, but I must stress that scoping reviews are primarily narrative in format. But the difference between this narrative and the narrative review that I mentioned above is that they have a much more extensive domain and scope, and as a result, it takes a lot of time, a lot of energy, and could be really expensive to conduct one, especially if your domain of analysis is widespread. And finally, Scientometrics or bibliometric reviews, which are used to measure and analyze extensive literature on a field of research. And they could be qualitative, but they're primarily quantitative. And the researcher or the analyst would leverage computational linguistics or network analysis or co-citation analysis, which is the main topic of discussion in this presentation. Allow me, please, to say a few more words about narrative reviews. And the reason for that is since my background is in language assessment, I found that most of the reviews that have been published in language assessment up until recently have been of a narrative nature. So narrative reviews are common, as you can see here. I don't know how many of you have read Alderson and Banerjee's 2-part papers about language assessment, or Lyle Buckman's paper, in which Lyle Buckman, who's one of the influential figures in language assessment, tried to provide expert opinion and synthesize the field of language assessment at the turn of the century. Then Alan Davis' work is very famous, and perhaps the most famous historian of language assessment is Bernard Spolsky. Actually, I have his very famous book here with me, Measured Words. If you have not read it, and if you're looking for a great work to get started on the history of language assessment, I highly recommend this. Many people in the field actually have a personal copy of this. This is not my personal copy, by the way. This is something that I borrowed out of the library. Okay, so Bernard Spolsky has written a lot. Cyril Ware has written a lot. Skian has written 2 wonderful papers. And most of these, all of these papers and books and book chapters are narrative reviews. In these narrative reviews, there is some common thread that weaves all of these reviews together. And what is that? It's the provision of experts' intuitive and experiential and explicit perspectives in focused topics. It's good to have experts' opinions and views about how the field is changing. However, there are also limitations to this type of review. What are the limitations? First of all, there is no database or no pre-specified methodology. So as a result, there are no research questions usually in these reviews because they're in the form of a narration. And as a result, the findings or the results have some qualitative meaning rather than quantitative meaning, which means that you cannot extrapolate beyond the small pool of papers that you have reviewed. In addition, specifically about language assessment, Spolsky in 2017 wrote that if you want to slice history into discrete approaches, which is commonly done in the papers that are reviewed with you, the slices do not necessarily are not necessarily equal to a record of advancement in language testing or language assessment, because this is what usually these authors have done. They slice the history into segments, and then they concatenate the segments together beside each other to arrive at a coherent progression of the field of language assessment. But Spolsky in 2017 says, actually, this is not the right way of doing it, and we cannot claim that such reviews really show the advancement in the field. As in his own words, it's not always clear that a new approach is derived from an older one, so one cannot argue that these add up to any record of progress in the field. For example, at some point, structuralism was kind of dominant in the field. Then it was gradually replaced with psychometric and psychometric structuralism and so on. What Spolsky says is that these different versions of language assessment are not necessarily an indication of smooth progress in the field. By the way, what I just presented is based on just 4 basic types of review. If you're interested to learn more about the different types of review papers, I suggest that you take a look at Chong and Plonsky's paper, which was just published in Applied Linguistics Review, where they review 13 types of review in applied linguistics, such as critical review, meta-analysis, methodological reviews, mixed reviews, and so on and so forth. Right, so with this figure, I want to preface the introduction to Scientometrics. This is generated using Sitespace. It's a beautiful graph, which basically summarizes a lot of information in the form of just one graph. And I mean, we could go through this graph and talk about it for hours, really, because there's so much information that has been nicely laid out in this graph that I think it will we would just need to spend like hours to discuss it. But I'm going to skip this, and I'm going to talk about Scientometrics in a different way. Scientometrics, as I mentioned before, is a type of review which I'm going to use in this study and showcase 2 investigations that we have published, just to show you how Scientometrics works. And also, another aim that I have in this presentation is to kind of encourage you to attend our workshop, which we will administer later. I think it must be in, I don't know, end of May or next month. I mean, Simon knows the dates, and he can actually correct me later. But the point is, this is like a taster to the workshop that we're going to present later on Sitespace. So Scientometrics is also known as science of science or science mapping, and is concerned with the quantitative features and characteristics of science and scientific research. There are many definitions available in the literature. I have chosen this one because I think it's very clear and elegant. Namalov in 1971 defines Scientometrics as the quantitative methods of the research on the development of science as an informational process. So what do we use Scientometrics for? The main themes in Scientometrics include the following. Measuring research quality and impact, and I'm sure that you noticed that I have included quality and impact in quotation marks. And at the end of this presentation, I will let you know why quality and impact are in quotation marks. Understanding the processes of co-citation, which is a wonderful and scientific way of doing things, and mapping scientific fields, as well as something that I don't really like, but Scientometrics and Bibliometrics are used for this purpose, and that's they're used as indicators in research policy and management. In other words, they can also inform policy and management and giving grants, research grants, or I don't know, declining people from research grants and so on and so forth. That's like the dark side of Scientometrics. Right, can we use Scientometrics as a tool? Of course, we can. As I mentioned, it's often used to evaluate the impact of publications and also impact of researchers, but also to identify key authors, journals, and publications related to a specific research area. So the first 2 bullet points that I am presenting here are common features between Scientometrics and Bibliometrics. Scientometrics has more exclusive or distinct characteristics as well, some of which I have listed down here, One of them is that Scientometrics can allow you to identify trends and patterns in scientific research, specifically by using co-citation analysis rather than citation analysis. As a result, it serves as a source of information for the literature reviews, particularly if you have a large data set, and it's kind of challenging due to the size and complexity of the field to do a comprehensive literature review and to draw conclusions and create a beautiful synthesis of the data that you have. Imagine that you want to synthesize the literature in the field of applied linguistics. We did it in one of the papers that I will just present. I guess I'm getting ahead of myself now, but I just wanted to tell you that we encountered a situation where we had around 50,000 papers to read. It's impossible to read 50,000 papers. So we need a data mining tool like Scientometrics to identify patterns in the data, those that are quantitatively meaningful, and discuss those patterns and their contribution and their implications for the field. Notably, as I mentioned, there is a technique called co-citation analysis, which is a valuable method for reviewing the literature in science. Co-citation analysis is used to identify clusters of related research and establish connections between different streams of work within a field. And if you want to read more about co-citation analysis, I highly recommend that you read Henry Small's work. Small's work is really fundamental to co-citation analysis. In addition, works by White and McCain, as I have cited them here, are very useful when it comes to co-citation and scientometric analysis. So let me tell you what co-citation analysis is. And I think after I explain this graph, you probably will figure out, if you are familiar with another term, which is bibliometric coupling, you'll find out, oh, that they are different, because that's a question that I'm often asked. So as you see in the figure right here, co-citation is the frequency with which two documents are cited together by other documents. For example, documents A and documents and B at the bottom are being co-cited. In other words, they appear in the references section of document C, document D, and document E at the same time. So here we'll say that the co-citation frequency of these two papers A and B, are 3. So then we can create a matrix, pretty much like a matrix of correlations. And but of course, the matrix is called co-citation matrix. And then fill in the cells by counting the frequency with which the documents, every two documents, are cited together. Then when you got the matrix, because it's all numbers, then of course the math or the syntax and semantics of data analysis takes over, meaning that you can submit the matrix to any sort of analysis that you like to. You name it, from community detection techniques or network analysis, social networks analysis, or other types of analysis such as clustering and classification and so on and so forth. So the main idea remains to be co-citation analysis. And if you're, like I said, if you're familiar with bibliometric coupling, you would know that it seems that co-citation analysis is a reversed form of bibliometric coupling. There's one more point to consider here. The more co-citations two documents receive, the higher their co-citation strength. And what does that mean? It means that they're more likely to be semantically and thematically related. In other words, in this case, there is a reason why some authors have decided that documents A and document B should be cited together. And if this pattern is reinforced in many other publications, then we assume that actually there is something that is most likely semantic that is common between document A and document B, and that's why people often cite them together rather than in isolation. Okay, we can use the same concept, the concept of co-citation, and basically extend it further. The the one that I just presented in this figure is known as document co-citation analysis. That's why the word doc or document has been used. Now, can we generalize this beyond documents? Yes, we can actually run author co-citation analysis. We can do journal co-citation analysis. In addition, countries co-citation analysis, where the authors from different countries co-cite other authors from different countries, and in the same way, institute co-citation analysis, etc. Of course, the term country co-citation and institute co-citation is not used commonly at all. I just use it so it will be in parallel with, for example, document co-citation analysis, etc. After we were done with co-citation analysis, then we will do visualization. We particularly do two types of visualization: timeline and time zone views, which I will provide you with some evidence later. And if you're interested to find the relationship between your field of research as an entirety with another field of research, you would use dual map overlay. This is the follow-up step after the co-citation analysis has been conducted. So here's an example to clarify further. In this example, which is adapted from Chen 2005, we have three types of co-citation events. The first one is author co-citation. As you see, I've just highlighted Green and Harvey. They have been co-cited together. And actually, everything else that you see on this list are co-cited together. And as a result, these people are said to be co-cited. Now, if another paper written by a different person or the same person, again, co-cites the same people, Green and Harvey, then the co-citation index for Green and Harvey will be 2. Here we've got 1. Then in that case will be 2. In the same way, document co-citation analysis applies to the green line. On my computer is green. I don't know what color it would be on your computer. Blue. Don't panic, it's blue, it's not green. So the blue color represents document co-citation analysis, because we're focusing particularly on the documents that have been co-cited. And finally, journal co-citation, I think is very straightforward. The journal anxiety disorder and trauma stress have been co-cited together. So this is a brief overview of what co-citation is, as opposed to citation statistics. Right. After we conduct the co-citation analysis, what do we usually do? We run cluster analysis on the matrix of co-citations that I just mentioned before. And what emerges as a result of this cluster analysis is a bunch of clusters or communities, if you will, which are related. And we need to know, as a researcher, what determines the content and properties of the cluster exactly. There are different ways of answering this question. I've gone through the literature, and I think Chen and Song have provided a very nice way of explaining how to determine the content in the first place and the properties in the second place of every cluster that emerges from co-citation analysis. What are the steps? Step 1. A hierarchy of keywords in articles needs to be created and needs to be mined using your techniques, the techniques that are available in software, which I will go through, that cite the cluster. So keywords in the first place to characterize the cluster. Number 2, the prominent members of the cluster have to be identified as the intellectual milestones in its evolution and as the intellectual base of that specialty. Please keep the term intellectual base in mind. I'll get back to this. It's one of the fundamental concepts in scientometric analysis, which, if I'm not wrong, has been introduced by Xiaomei Chen himself, the developer of CiteSpace. The other thing, number 3, is recurring themes. In the citing articles to the cluster to reflect the interrelationships between the intellectual base and the research front. So another term comes into the profile here. That's research fronts. we need to find out what research front is, and I'll explain that in a second. And last but not least, we need to pay heed to indicators of the evolutionary stages of a specialty, such as the original conceptualization of that subdomain or specialty, and research instruments that are using that specialty, as well as applications and routinization of the domain of knowledge in that specialty. If you don't mind, I quickly go back to this photo this graph that I showed you before. We're talking about specialties within this domain of knowledge. The first specialty, as you see on top of the hierarchy, is bacterial pathogen, and it started from maybe 1990, between 1995, 1996 and 1997, as you can see right from the little circle on the left-hand side, and it has continued all the way up to 2002. Yeah, I have a bigger screen here. I can see it better. The 2002, and it has just ended there. So this is considered to be one specialty. Then now you need to go into this specialty and see what is going on within this area of research and so on. This is not really related to language assessment or applied linguistics, but I find that it's very useful because the data is neat and very easy to analyze using Cytospace. Okay, so I want to go back to what I was talking about here. It was number 4. So the original conceptualization has to be looked into. The research instruments that are used in every specialty or every subdomain, their applications and routinization must be taken into account. Now, I was also saying that there are 2 terminologies, intellectual base and research fronts. And we got to talk about that a little bit as well because they're important. Like I said, Xiaomei Chen has come up with these 2 terminologies, and I find them to be very useful. Intellectual base refers to a set of core articles, authors, or concepts that have been widely cited by researchers in the field. They usually represent central ideas, sometimes dogmas, ideologies, theories, and methods. Think about some of the most outstanding works, which were probably published quite several years ago, maybe 15 years ago, 20 years ago, 30 years ago, and people are still in your field of research are still using them. They're referring to them, they're citing them, they're justifying their research design with reference to those papers or those people who published their work many years ago. That is the intellectual base, and it's very important. It's like the pillar, the foundation of every branch of science. As you can imagine, intellectual base can get outdated over the years, and that's why when new research emerges, there's usually a period of chaos at the beginning of the emergence of new research, because there might be a little bit of conflict between research, and sometimes actually more than a little bit of conflict between research, between intellectual bases and the new research which is now emerging. The new research is known as the research front because it's right in front of everything else. It refers to the cutting edge and emerging topics in a research domain. So if you want to characterize research fronts, I would say they're recent, they're rapidly evolving, and importantly, you can identify clusters of more recent articles if you do co-citation analysis, and authors and concepts that exhibit a high level of co-citation. For example, when you run the co-citation analysis, you see that, oh, there's a new group of people who are citing each other, but they are kind of isolating themselves from the rest of the population. But this group of people is growing. Although there are some links between them and the rest of the population, the inner links of the group itself, that's the cohesion and tightness of the group, to use the terminology in Scientometrics, is much stronger than the edges, which means relationships, between the group and other groups. So this group is the research front because they represent new directions and potential breakthroughs in the field and can be valuable for identifying future research opportunities and trends, sometimes this is a harbinger of a true paradigm shift, if you will, a revolution in that field, something that completely turns everything upside down on its head and presents something new. I mean, in science, the example I usually provide is when Albert Einstein um, came up with the general theory of relativity. A lot of people didn't like it, but then physicists realized pretty fast that, well, he is offering a new paradigm, and they went, which goes beyond Newtonian physics. A thing like that refers to research funds, cutting edge and emerging topics, which do have the power and affordance to bring about a revolution or paradigm shift, if you will. Now you can think about your own fields and domains. Has such a thing ever happened in your field or domain? I would be very happy to listen to you if you think that you know of some cutting edge emerging topic that is now making the rest of the topics or the rest of the methodologies that were being commonly used obsolete. Okay, I hope you're not tired. I made this slide particularly because I thought some of you might ask, so if I do a scientometric analysis, what should I exactly do? Of course, I will talk about this mainly in the workshop later, but here is a preface to that. Let's imagine that you have conducted your scientometric study and the data is being churned out by the software that you're using. There are two important things that you need to report. Number one, temporal metrics. And number two, structural metrics. What are they? Temporal metrics are of two types: citation burstness on the one hand, and sigma. Citation burstness refers to a sudden increase in the citation count of a publication. And I want to stress on the word sudden. It's not a continuous increase. It's like a peak. That's why we call it a burstness, as if, you know, it's like an explosion of citations. So it's a sudden increase of citation counts, and it's important. It ranges from a minimum of 0. Of course, that's the beginning of citation. You always start from 0, and it just goes up. There's no ultimate limit for that, no upper limit for it. Sigma is another terminology which refers to an indicator of science novelty, and the larger the sigma, the more novel the paper is. The paper probably is. So if you get a sigma of, for example, 10, 20 or so, compared with the rest of the population or the papers in your data set, you can assume that there is some novelty, something new in this paper. That's why it receives a high sigma value. And to calculate sigma, you don't have to have this sudden increase. You just use the formula which is based on the continuous increase of the number of citations. The other three metrics are structural metrics. One of them is the average silhouette score. Those of you who have worked with machine learning or clustering techniques like k-mean index, you may be familiar with the silhouette score. And yes, it's exactly the same silhouette score that you would use in that domain. Silhouettes, as in all domains in machine learning and k-mean clustering and just clustering, basically refers to the homogeneity and accuracy in clustering, and it ranges between -1 and +1, with values closer to 1 suggesting high precision. In clustering, the values that are 0 suggest that, well, this publication, we were not very sure whether it belongs to cluster 1 or cluster 2. So it just indicates uncertainty. And if you get a negative silhouette score, you're in trouble because something has definitely gone wrong in your analysis and you have to redo the analysis. Based on my experience, a silhouette score above 0.3 is good. 0.5 is definitely better. And if you get anything above 0.5, you must be very, very happy about it. Hopefully, you will never get a minus silhouette score because something has gone wrong in your analysis. And then there is another index called modularity Q, which also ranges from -1 to +1, and it's a measure of clustering quality, or whether the network can be broken down into discrete clusters. In other words, it will tell you whether the members of a cluster actually belong to that cluster or not. So in a sense, it's an indicator of cohesion and tightness of your clusters. And last but not least is between a centrality, which is a degree to which a node or a paper in this case is located between two or other nodes. Imagine you have two friends, friend A and friend B. Now, friends A and friend B do not know each other, but you do know both of them. So you are the person who is right between these two. So you are creating a very simple network. It consists of three people. But the point is, if you're removed from this network, it immediately collapses because these two guys or girls, for that matter, have no connections with each other because they only know each other through you. And imagine that you have a large cluster in which you have someone right at the center and everybody else is connected to this person or to this document because they are co-citing this document. So this co-cited document at the center of this cluster is very important, and as a result has a very high betweenness centrality. Therefore, it indicates the number, the index betweenness centrality indicates significance of the paper. Okay, another thing I would like to say is after you have identified the clusters, you can do other innovative things. One example is this. I did this with the help of Ling Eng, my former research assistant. That's her photo over there. You can create themes and clusters. We have explained this in the paper published in System. If you like, please go through it. But this is called a codex. So there are different ways of visualizing your data, and as you can see, I'm really very much interested in visualizing the data that we get to see, and also also reporting, of course, the statistics that I mentioned before. Now, so far, if you're not tired, I have presented a brief overview of what Scientometric is and how it can be done. At this point, what I would like to do is to present the results, some of the results that we have achieved in these two papers that is right in front of you on the screen. One of them is an extensive knowledge mapping review of language assessment, and the other one is a scientometric analysis of applied linguistics research, where we focused on methodology and future directions. Again, I should say that in the interest of time, I'm not going to go through everything that we did in these studies. What I would like to do is to just showcase some of our findings there, which I felt would be interesting for you. We followed this step more or less in both of the papers. So if you like to have an algorithm in mind, which helps you to do scientometrics analysis step by step, this is probably something that you could use as your starting point. First of all, you need to define your research parameters. Specifically, what do you want to do? If you are interested, you can create a Prisma chart. You can just Google Prisma, Prisma, and identify and define your parameters using that Prisma chart. So you will not include papers that are not relevant to your field of research. The second step is to identify publications and create a data set. I usually use Scopus and the Web of Science and compare them, of course. Sometimes you can combine them to create a better and more representative data set. But I understand that some people do not have access to these two databases because they're expensive. Well, there's another solution for you. The solution is you can use a database called Dimensions with an S, plural S. You can Google Dimensions and Bibliometric data, something like that. It's free. That's a good thing. You just need to create an account. But one of the potential shortcomings of Dimensions is it has a high rate of false positives. So you will get papers that are not directly related to your field of research. So you have to go through the papers and do some screening and cleaning, which usually takes much more time than if you used Scopus and the Web of Science, but it's still worth it. And it's very useful. The next step is to visualize the intellectual structure of the chosen fields I mentioned before, then assess the quality of the networks using structural and temporal statistics, which I also mentioned. There is another step which we have used in this paper right at the bottom in Target, which was published, based on Shulian Zhu's PhD work. It's network comparison. We figured that actually, since we identify the parameters of the network, why don't we change the parameters and then compare the different networks, which are based on different parameters, to figure out which one is the best. It turned out to be a useful method, because when you change some of the parameters, you'll get a more accurate and better representation of the data that you have. Then you will determine significant research clusters, and finally you characterize the clusters by going through the clusters, by going through the papers, and see what really connects these papers with each other. So it's more like a qualitative stage, and it takes quite some time. So some people just conveniently skip that stage. All right, so study 1. In this study, we wanted to identify the intellectual structure of language assessment research published in English peer-reviewed journals. We created 2 data sets using Scopus. One is the core journal data set, which consisted of 1561, that's 1,561 articles from these 4 major journals. There are many other major journals in the field of language assessment. I would say a few more, if not many. But unfortunately, they were not indexed in Scopus back then, so we only had access to the data indexed from language testing, assessing writing, language assessment quarterly, and language testing in Asia. Then we also created a general journals data set, which consisted of 3,175 articles on language assessment published in the journals of SLA, second language acquisition, and applied linguistics. We chose the so-called top 20 journals as ranked in SciMago. I should have put quotation marks around 20, because like I said, I don't really want to quantify quality in a sense. It might sound ironic and counterintuitive, but I wouldn't reduce everything to numbers and statistics, even though I'm a university professor who is constantly teaching statistics and stuff like that. Okay, so this is just a screenshot of search parameters in Scopus. After you include your parameters, you'll get something like this, which is just an example to show you how Scopus works. And then you need to decide what kind of tool.
I'm sorry, Dr. Aryadoust. We have 10 minutes left toward the end of the session, which means 5 minutes
Okay.
for Q&A. Thank you.
Okay, sure. Thank you very much. So this is a list of free software packages. I don't go through them. You can take a screenshot, and if you like, you can download them. The good thing is that they're free and they're very useful to use. They're very easy to use. For example, VOS Viewer at the bottom is extremely user-friendly. So if you want to get started with Scientometrics, I recommend VOS Viewer and, of course, SiteSpace. So here is a screenshot of some intellectual structure in the field of language assessment. I wanted to highlight quite a few things, but in the interest of time, what I want to highlight is look at the colors. Colors represent betweenness centrality. So where you've got warm colors, for example, redness and yellowness, or yellow is not that warm, but orange, the orange color, it indicates that your clusters have tightness and cohesion compared with the clusters that are in blue or green and colors like that, which are kind of cool or cold colors. And it means that cohesion of the cluster is not as high as the rest of it. And you also see that there are labels per cluster. These labels have been generated automatically. We experimented with 3 algorithms to generate these labels. They're known as latent semantic indexing, log likelihood ratio, and mutual information. To the best of my knowledge, and as far as we could experiment, the best one among all is log likelihood ratio, and that's something that Xiaomei Cheng himself also stresses. So if you want to find the best label for your clusters, I recommend LLR is a good one. I'm going to skip this and go directly to another thing I wanted to show you. Here is the list of bursts that appeared in our data set. The bursts are arranged based on the strength of the bursts. As you see, Bachmann and Palmer have the highest amount of burst, that's 17.39. The frequency of citation for Bachmann and Palmer in this cluster, that's cluster 0. 0 indicates the largest cluster. Is 63, which means that Bachmann and Palmer's work has been cited 63 times within just this cluster, not in the entire, of course, network. And then we've got centrality and sigma, which, as I defined before, indicate how important the publication is and how novel the publication might be. In the same way, we did the same analysis for the general journals, and Bachmann 1990 just came out to be the first one on top of the hierarchy and so on. So again, I really have to skip the rest of the analysis. This is the analysis of that was reported by Zakaria and Aryadoust, myself, in another research paper. What I wanted to say is scientometric analysis, bibliometrics, and numbers by nature are limited because there is citation bias. For example, if an author is more famous, or if the journal has more prestige, or due to language barriers, chances are that some papers get more citations or they get more co-cited, whereas other publications do not get as cited as much. Then there is always a time lag between when the paper is published and when it becomes a burst. Sometimes it takes a year, sometimes it takes 5 years, sometimes it takes much longer for that paper to become important in that field. And there's another reason here why we should not put all our eggs into the basket of co-citations, and that's the inability to discern citation context. Yet I don't know any methods so far within the realm of co-citation analysis that can identify the context. By that I mean, if you do bibliometrics or scientometric analysis, you wouldn't know why this paper has been cited so many times. Is it because people are citing it positively or are being critical of it, or are they just being neutral? And that's something important, I think, in the future work. If anyone is interested to work on it, this is a good research problem to address. I'm just cherry picking some of these bullet points that I have presented. The last thing I wanted to say is that methodological papers and review papers, as well as controversial papers, as the research shows, have a much higher chance to be cited more. So the nature of the paper that you write also determines how many times it's being cited. Now, of course, we can argue and discuss why it's the case, which I'm afraid I don't have enough time to go through. If you want to read more about the predictors of citation, these 3 papers are recommended. Zhang Sai, my master student, provided this list for me. If you like, you can take a photo of it and later on check them. They're great work. And with that and references, I would like to thank you very much, and sorry that I kept talking, and actually I probably prepared myself for a 1.5 hour presentation, which I guess I was wrong.
Thank you, Dr. Aryadoust. It was really informative and really important. Thank you. And as Dr. McKinley just mentioned, the limitations that you have mentioned, they are really important, and he actually thanked for highlighting them. Thank you so much. And we have a question from Dr. McKinley, and he has asked that, I'm quoting directly, what are your thoughts about checklists like Prisma, in parentheses, an evidence-based minimum set of items for reporting in systematic reviews and meta-analysis for assessing quality in such research?
Oh, thank you for that question. That's a great one. I think it provides you with something like an algorithm because it takes you through the steps. So I would say it's not a bad idea to have something like a Prisma, because in the interest of reproducibility and transparency, I think Prisma can help you and your reader particularly, about the steps that you have taken, the problems that you have encountered, and everything will be relatively transparent when you have a Prisma. So if you're asking whether it's a good idea to use Prisma, I highly recommend it. Yes, it's a good idea to use a Prisma chart.
Thank you, Dr. Aryadoust. Thank you so much for everything that you have provided us today. And
Sure.
I think, Dr. Chang, there is a question related to, sorry, a new reply by Dr. McKinley. He says, I was hoping you would be favorable of using Prisma in this way. I had to ask because, of course, it's not designed for assessing quality. Okay, thank you. And about Dr. Chung, there is a question which I think refers to our event today. Nasser has asked if the slides will be provided, and also how can I mean our audience or the uh, network can have access to the recorded file. Thank you so much, Dr. Aryadoust. And I think I will mute myself and turn off my camera, and I leave it to Dr. Aryadoust to have a final word, and also Dr. Chang. Okay, thank you all.
Thank you,
Thanks,
Mehdi.
Mehdi. I'll just respond to that request. I think the event is being recorded and it will be available on our SIX website very soon. I will discuss with Vahid about the slides, and we'll get back to you if you know a version of the slides can be made available, and that is something I can do. And just to thank Vahid very much for that very informative talk. I think it appears that not a lot of questions are in the chat, but I'm sure we have a lot of questions, but simply because there is a lot of kind of information, and I think it's a very rich talk and a relatively new, methodology in applied linguistics. I'm sure people are still digesting it, and there will be many more questions to come. And it's good that Vahid recommended a few of his papers and other related resources that people can check out later. If you feel like it's not enough because it's only an hour, then you're right, because we designed it to be that. Vahid mentioned earlier that we'll have a sort of online summer school later this year. So for our sake, so every year we have like a theme, and this year the theme is bibliometric and scientometric review. And so we have like a taster session today, which Vahid gave us an overview of this specific type of review. And we will, Vahid and his colleague will be running a virtual and online summer school for us in early August, and the dates to be confirmed and details to be confirmed, but Vahid has agreed. So it will be a 3-day online workshop where Vahid will walk us through the steps, especially using some of the software, running some statistics, working on some examples. So it will be very hands-on. There will be a fee for that, obviously, because it's a lot of work for the speaker, but do keep in touch if you're interested, and I will disseminate the information as soon as it is available. So I just want to thank Vahid one more time for the talk and for kicking us off in 2023 in relation to SIG activities. Thank you, and thank you, everybody.
Thank you very much, Sinwang, for the invitation. It was really nice to see you and to have wonderful participants on this panel.
Yeah,
I look
me
forward
too.
to the workshop in
Thank you
August. It
very
was in
much.
August. I thought it was in the summer, so
Yeah,
it's in
it's
August.
early August. We'll work out the details later. Yeah, thank you very
Wonderful.
much. And thank
Thank
you,
you.
everybody, for participating, and I hope you have a nice day. Cheers, everybody.
Thank you.
Bye.
Have a good day. Bye-bye.